Hello and welcome. Sometimes strange things happen, and today I'd like to tell you a story about a donation with a sad but also slightly crazy background. One of my old times friends from Russia grabbed some retro hardware from his garage and asked me if I would like to have it for my channel. This was about 2 years ago. First he wanted to send it to me by a delivery service, but then we decided to wait until the end of the pandemic and see if we can meet personally. Well, pandemic was mostly over, but one senile and angry guy decided to break the world in his agony. And there they were, our plans drifting away. My friend has a big family and can't leave Russia easily, and I can't, and honestly am not keen to travel there now. Well, in these cruel times, not only Ukrainians are running from the war, but also quite a lot of Russians, which are either in the opposition or simply not agree with the war which the regime put on them. They protested, and for many of them it is not safe to stay there anymore. I prefer not to call the names because I don't want to get anyone in troubles, but luckily I could help some guys to get out, and funny enough, some of the parts which my friend in Russia sorted out for me traveled in a case of the runaways stuffed between the underwear and socks. First from Russia to Turkey, then from there to Spain and eventually to Germany. And here it is, the pile of hardware which I named the Echo of War. Let's see which parts had to travel so far, hiding in a pile of socks. This is a very interesting packaging. I already looked through a gap what it is, and there inside are some CPUs. Let's put it to the end for now. And next one is an ISA Super I/O controller for IDE hard drives, floppies and I/O ports. A quite useful part needed in every 286, 386 and early 486, where such controllers were not yet integrated on board. The card seems to be slightly damaged. There is a ripped off capacitor which needs to be replaced. Some pins are bent, but nothing what couldn't be easily fixed. This is a Gold Star controller, which was very common back in the days. They existed in various models and revisions, but they were all very similar. Only the layout of the PCB was slightly different. Okay, the next part. It is an ISA VGA and EGA graphics card. It is based on the ATI 28800. Actually a quite rare card, to be honest. This is the first time I hold one in my hands. It has two DRAM ICs with total of only 128 kilobytes video memory. But there are two more sockets where another 128 kilobytes of memory can be added. On the connector side, we have on the left the TTL CGA EGA monitor connector. In the middle, I think this is a bus mouse connector, but I'm not sure. And on the right is the usual 15-pin VGA connector. Well, a very interesting card for a 286, I guess. The card is a little bit dirty, but that's an easy to fix issue. The next card is, wow, in quite a bad condition. There is a lot of rust on the brackets. Anyway, this is not a very interesting piece of hardware. It is an S3 Trio 3D. However, I'm surprised to see such a card as an AGP version. I actually don't see the reason. This is actually a good 2D video card for office use and DOS gaming, but for 3D it is an utter crap, and PCI is more than enough. Probably this was kind of a marketing trick, because AGP became so fancy at the time. Well, this card is also very dirty and oxidized. Furthermore, on the chip there is a note made with a pencil in Russian, "Glючит," which means as much as glitchy. So I guess it was bad even before it started to rust. But well, I'm still curious, so I'll clean it and see if it produces any image. Oh, this is a really neat one. A quite rare AGP graphics card. 3DFX Velocity 100. Didn't see one for years. This is a cut-down version of the Voodoo 3 2000. And it was installed mostly in the OEM machines back in the days. The first cost reduction was the memory. A usual Voodoo 3 2000 had 16 megabytes of SD RAM, where the Velocity 100 had only 8 megabytes of SG RAM. only half the size. That's why this card couldn't support higher resolutions. I think 1024 by 768 at 16-bit colors was maximum in 3D, and it also could be slightly slower in some later games. On the other hand, the memory on the Velocity 100 was a bit faster, so it could compensate the speed loss and in some rare cases even outperform the Voodoo 3. The second limitation was an artificial one. 3DFX wanted to get into the cheap OEM market, but didn't want to create a competitor to the Voodoo 3. So they deactivated one texture unit in the GPU to make the card slower. However, this has been done in software and could be easily turned on in the Windows registry again. So effectively this is a 3DFX Voodoo 3 with half the memory, and later 3DFX even released this card to the retail market under the name Voodoo 3 1000, as far as I remember at least. This is a really great card for a retro machine. Oh, and the last card is a real treasure. It is a VLB card based on the chip's F64300 video chip. I never had a chance to test such a card, but from what I heard, this belongs to the faster VLB cards and should run almost as fast as the ET4000 W32. But the speed itself is not what makes this card special. It is the technology which was used. As you can see, the card has 8 DRAM ICs with 1 MB of video memory in total. In addition to that, on the right we have 8 sockets for another megabyte of memory, which would allow us to use resolutions up to 1024 by 768 at 16 bits. But the unusual thing is that there are 2 more sockets on top of the memory ICs, which can be used as cache, theoretically improving the performance in Windows. I'm really curious to make some benchmarks with this card. Well, it is dirty like most of the other cards and the bracket is missing, but otherwise I don't see any damage. Now back to this package. As I saw it first time, I asked the carrier if he was asked on the border what this is and how he came to the idea to pack it like that. Well, he just said that he doesn't want to talk about it. And I had following on my mind.
In one place he knew he could hide something, his ass. 5 long years he wore this watch. Up his ass.
Whatever. Sometimes it's better not to know everything. Back to the topic. This is a Socket 5 Pentium. It is a 60 MHz version, and those are quite rare and expensive today, especially the ones with the infamous FDIV bug. The very first revision of these CPUs had a critical bug in the floating point numbers division. Intel had to replace thousands of CPUs worldwide. It costed the company almost $500 million and even crashed Intel's stock on the market. However, today it is nearly impossible to find a buggy revision of this CPU. And not only the Socket 5 CPUs are rare, but the main boards for such CPUs are even harder to find, and unfortunately I have none. So this CPU will go into my collection untested for now. The next one is an AMD 486 DX2 66 MHz 3V CPU. Nice, since I don't have many 3V 486 CPUs left for testing. And here is an Intel Pentium 100 for the Socket 7. Also a good CPU for mainboards testing and repair. A Socket 370 Celeron 466 MHz. And this is an Intel Pentium 166 non-MMX. Very interesting. I didn't know that this CPU was released as plastic PGA as well. I thought Pentium 200 was the first one, and everything before that was ceramic packaging. On the next CPU the pins are heavily bent. It is again an AMD 486 DX266, but this time it is a 5V variant. As you see, the pins are really in awful condition, but nothing you couldn't do with a pair of tweezers. The next one is an Intel 486DX4100. That is great, because so far the fastest 3V 486 CPU which I had in my collection was a DX2 80 MHz version. Really happy to get this one. The next one is a Cyrix DX2 66 5V CPU. This is a really cool one, not only because it was a completely custom development by Cyrix, but literally cool because despite that it was specified for 5V, many of those CPUs ran stable even with 3V and could be used completely without a cooler at that voltage. Also here the pins are heavily bent. Oh, that's getting really nice. Another 100 MHz 3V 486 CPU, this time by AMD. It is very dirty and the pins are also bent, but I hope it is still alive. And the next one is an AMD K6 233 MHz. This one comes also very handy for one of my projects. And the last one is the AMD K6 350 MHz. I think I have a couple of those in my collection, but for testing it is always good to have another one. So here are the guys, and I'll have a lot of fun cleaning and testing them all. And before I got to wash everything, I wanted to test a trick which Phil from Phil's Computer Lab presented not so long ago on his channel. I wanted to try to remove the rust from the bracket and the VGA port. You can find the link to Phil's video in the description. Some sodium carbonate and a little bit of water to make a paste of it and rub it into the bracket. After some minutes of waiting, I added some white vinegar and tried to clean the rusty spots with a toothbrush, but that didn't work as I was hoping. Maybe it was too rusty to make a real change. Well, at least I tried. And here I am a couple of days later. Everything washed with soap and water, just as I always do. And after some days drying, I tested all the parts and here are the results. Let's start with the S3 card. As I said, except that it is an AGP version, there is not much exciting about it. Still, I decided to give it a chance. I could change the VGA port completely, but I didn't want to waste too much time. So I just removed the rust with a metal brush and polished the surface a little bit to be able to connect the VGA cable at all. And fun enough, the card was alive. Well, at least in DOS. I didn't test it in Windows so far. I noticed, however, that the chip got quite hot, to be honest. And that could be the reason why on the chip was written that it is glitchy. Maybe it overheats after a while and needs some cooling. Strange for a S3 trier, to be honest. Another thing which I noticed is the black bug, which is very common on all S3 cards, where in low resolutions and text mode the black color is shown as gray. What makes the image really bad? The easiest way which I found to fix this is to go to VGA Museum, download the BIOS from another S3 card, they are usually very similar, and use that instead. Some of the versions fix the bug and you can get the proper black color. However, sometimes the core and the memory clock can be lower or higher. So you have to check out that it is in limits. Well, unfortunately, the trick with the sodium carbonate didn't work on the bracket, but the card itself is at least working in DOS and is good enough to be used as a test card. The Super I/O controller is half working. IDE serial and parallel ports seem to be okay, but the floppy controller seems to have some issue. If I'll have some spare time, I'll have to take a close look at it. At least all the pins now are straightened again. This one makes me really happy. This card seems to be completely okay. And I think this is not the last time you see it in my videos. The ATI, EGA and VGA card is working too. I didn't test the EGA output, however, but VGA works just fine. Interesting is that it didn't want to work in faster PCs like AMD K6 2500 and Pentium 3 500, but as soon as I used it in a 486 or slower, this card worked just fine. Now to the chips VLB card. It is absolutely working and I already made some interesting tests, but I would like to make a separate video about it, because it is so rare. I also would like to make some benchmarks on Windows 3.11, so my question on you guys, please write into the comments which benchmarks would you like to see. In DOS, there are plenty of usual suspects, but which VGA benchmarks do you know for Windows 3.11? I hope to make a video and present some runs against another cards, and also I would like to see the difference with and without the cache. Now to the CPUs. Well, in short, except one, all of them are running, but the pins were heavily bent and it took some time to straighten them. Unfortunately for the AMD DX4100, this didn't work all that well and 2 pins broke off. But this can be repaired, and here how I do it usually. I put some flux on the pad of the broken pin, then I add a blob of solder where the pin can be soldered back into. I tried to put back the original pin, but it is quite hard to make it right, to be honest. So instead I'm usually using a piece of longer wire because it is easier to hold it in place than a smaller pin. And it is very important to get it straight, because otherwise it will not fit into the socket. After soldering the wire, the long end can be simply snapped off. And this is how the 2 pins eventually look like, which were broken off this 486 CPU. Well, just as I said, I can't test the Socket 5 Pentium CPU because I simply have no such mainboard. And by the way, this revision is not the one with the FDIV bug. Still, it is a rare CPU and it will wait in the box for its time. All the Socket 7 Pentium CPUs did work fine, and the only one non-working CPU turned out to be the Super Socket 7 AMD K62-350. It gets warm, but seems to not to show any signs of life. I'm very happy that everything else works though, since I have a couple of K62 in my collection already, so it's okay. And all of these CPUs are really useful for me. Even the boring Celeron 466 is a great option for testing, either standalone in a Socket 370 mainboard or in a slot 1 in such an adapter. This CPU runs at 66 MHz and can run a minute or so without a cooler, so it is a perfect candidate if you need to check out if a mainboard is alive. All this is a great computer history, and I'd like to thank my friends for these parts. I'd only wish I wouldn't get them under such sad circumstances, where I'm even afraid to say names. I'd wish that the war in Ukraine wouldn't happen, people wouldn't die, cities wouldn't be destroyed, that the Russian people with the heart on the right spot wouldn't be repressed and wouldn't have to run away. It is ridiculous how these parts came to me, and I wish from my whole heart that in the near future we can meet again in person without fear, and send each other such nice packages instead of bombs and weapons. Thank you and goodbye.